when you read a data sufficiency question, try to understand what question is behind the question. What is the true question? Or what needs to happen in order to give a unique answer to that question? What are they really asking? All right? For example, if you are asked whether x squared equals 9, then you know that for this equality to be true, x might take the value of 3 or negative 3. So the true question is x equal to 3 or x equal to negative 3? In either case, you would get an affirmative answer to the question. Okay? When you start evaluating the statements in a sufficiency question, try to use properties of numbers, that is arithmetic or algebraic properties, to validate in a more general way whether the statements are sufficient. For example, we saw that if you are given this statement that x plus 1 is positive, you might write values, but instead, if you represent this in a more general way using the algebra of inequalities, then you can get to the correct conclusion. By isolating variable x, you get to this inequality that clearly implies that x doesn't have a unique sign. If the question, for example, here was, is x positive? Then you know that this is not sufficient if the question is this, because a number greater than negative 1 might be positive or negative. So using these general methods to validate the sufficiency of statements is highly recommended. Now, what happens if you cannot use specific properties or generalizations that may help you conclude whether there is a unique answer? Okay, you can try values. This is what we did in some of the examples before, right? When you plug in numbers, different numbers for the variables that appear in statements, and you get different answers to the question, then you validate the insufficiency of the statement. But if you notice a pattern, no matter which values you pick in different ranges, in different possibilities, fractions, decimals, integers, and you continue obtaining the same steady answer, then you have also to accept the evidence and conclude that the statement must be sufficient. This is exactly what happened to us when trying values for this, right? When y is defined as the product of 3 consecutive integers, y has to be always divisible by 3.